Here's a problem from the textbook. We've got this data, some x and y values, and we want to, let's worry about problem number 2. We want to produce the vectors and so on. So it's looking for some R code. I'll actually pull up an R compiler to put this in. Okay, well look, how do you go about producing a vector? The key in producing a vector is to use the concatenate function. So we want to use the concatenate function, and we want to have the x values in there. So 20 and 20 and 17 and 5 and 10. Okay, and we might as well store that in an object called x, because that's what it's supposed to be. It's supposed to be the x vector. So produce a vector x containing the data from the table for the x values. Okay, that's it. Okay, so can you, with that much information, say, well, how am I going to produce a vector for y? Well, it's got to be a vector that contains 8, 12, 14, 10, and 11. And we might as well call that an object x. So we use the concatenate function, 8, 12, 14, 10, and 11. Okay, super easy. Now that's kind of the munging or the wrangling stage of the data processing. We needed to get this data into R somehow. So now it's in R. We've got this object x and this object y. Look how easy it is now to find the sum of x. There's just a command that says sum of a vector, and that adds up the values in that vector. A sum of y is going to be very easy to find as well. So how about the sum of the x squareds? So we want to square each one of the x's and then add them up. So that's going to be the sum of the x's squared. Okay? Let's just pause and we'll build this script in a minute. Let's just look at x squared for a minute. Let's execute the script as far as we've done it. So there we are. We're building this vector x, first of all, that has 20, 20, 17, 5, and 10 in it. It doesn't get printed out. It's just being stored in that object x, and the y vector is just being stored there. So if we add up all those x's, it becomes 72. Look at that. 20 plus 20 is 40, plus another 10 would be a 50, a 67 plus a 572. I figure out, get out your calculator or something, just add up those numbers. That's what they are. Okay, the sum of the elements in the y vector is just going to be the sum of the y. And notice what happens if we look at x squared. The square of 20 is 400. The square of 20 is 400. The square of 17, 17 times 17 takes a minute to work that out, but it's 289. 25 squared, 5 squared is 25, and 10 is 100. So if we change this then and looked at the sum of the x squared, then that's doing the same thing that this command, that this algebra command is. The sum of the x squareds. Okay, square each one of the x's and then add them up. So that's going to be that amount. This one is different. I want to add up all the x's and then square that amount. So I need to add up all the x's and square that amount. Okay, great. And then finally the last one, I want to add up a bunch of things. What I want to add up is x squareds times, now remember in R you always have to put in the time sign, y. Okay, how easy is that? Look how similar the syntax is in R to the syntax of this kind of notation that people use in statistics all the time. So there's the results, and There's the R code. That's what was asked for in this problem. And there's the results from each of those R codes. Okay, hope that helps.